Welcome to the introduction section of virtual instrumentation. So in our final year, we are going to discuss about what is the importance of virtual instrumentation related to the industrial environment. So as we know, instrumentation deals with measurement, monitoring and control of various parameters. So we need to build a good infrastructure for the measurement such that the safety of the plant is established. So we need to build a good hardware and software in the environment where the safety and productivity of the plant is maintained in a balanced condition. So the virtual instrumentation part deals with the instruments which are being designed and developed to measure the parameters, monitor the parameters and control the parameters as per our industrial needs. This curriculum is divided into 4 units, which are the fundamentals of virtual instrumentation. Since it is a huge subject, we have limited our learning to only few basics in our curriculum. The first unit deals with the introduction to virtual instrumentation. What is the historical perspective of virtual instrumentation? How virtual instrumentation started from the scratch, that means from sensor to the modern day intelligent sensors. What are the building blocks of virtual instrumentation? What is the architecture of a virtual instrument? What are the programming techniques which are used for the design and development of virtual instruments? What is the difference between the programming in virtual instrument when compared to the conventional programming? Again, how programming is achieved in virtual instrument scenario. So the first part of the first unit deals with the architecture of virtual instrument, the comparison of the virtual instrument programming to conventional programming methods. The second part of the first unit deals with virtual programming. That means how to program a virtual instrument, how to design and develop a virtual instrument basing on the programming that is used in virtual instrument software development environment. So what are VIs? What are sub VIs? Loops and charts, arrays, clusters and graphs. Here we will also study about case and sequence structures, nodes, local and global variables, string and file input and output, instrument drivers. That means the first unit of the virtual instrumentation deals with the basics of the virtual instrumentation which are used in industrial scenario. The second unit deals with the VI interface requirements. That means how to interface the VI with the industrial parameters. That means what are the bus that are being used in the industrial scenario, what is the importance of the current loop, what is the importance of RS-232, RS-485, what is meant by Ethernet control of PXI, how data acquisition hardware is used to acquire the data from the sensors, what is the role of the virtual instrument in acquiring the data by using data acquisition system. So all these aspects will be discussed in the second unit. So the second unit is related to the interfacing of the virtual instrument to the industrial environment. This is a quite interesting topic which we will be discussing in the second unit. Now the third unit is related to what is the role of virtual instrumentation in modern applications. Of course, this is a very broad areas, but to take few examples into our curriculum, we are going to discuss about instrument control using RS-232 and IEEE 488, development of virtual instrument using graphical user interface, what is the importance of ActiveX programming, how to publish the data in the internet website, how to go for embedded controller by using a virtual instrument, what is importance of OPC. So these are nothing but a few examples which we'll be covering in our third unit in virtual instrumentation. So the third unit is a little bit applicative awareness about the industrial environment, which we'll be taking few examples. The fourth unit is related to what are the tool sets which are available in virtual instrumentation. So of course there are many tool sets which are being developed as per the need of the industry nowadays in modern scenario. So but here we are going to discuss about distributed input output modules, control design and simulation, digital signal processing, image processing and motion control toolset. These are nothing but a few toolsets which are being discussed in our curriculum. Of course, as per the industrial needs, we have to incorporate more number of toolsets and to develop more number of virtual instruments for modern scenario. So in industrial applications, we need to develop various virtual instruments as per the requirement of measurement, monitoring and control of the parameters. So in order to build and develop virtual instruments, we need to go for a software environment. So what is the software that is used to build and develop virtual instruments? For this, the answer is Labview. Labview is developed by a company called National Instruments. This company developed the Labview software to build virtual instruments for the modern applications. So Labview offers a graphical programming approach that helps you visualize every aspect of your application, including hardware configuration, measurement data and debugging. This visualization makes it simple to integrate measurement hardware from any vendor, represent complex logic on the diagram, develop data analysis algorithms and design custom engineering user interface. That means whatever we want, we can design by using a Labview. So that means a Labview is a software environment where we can build and develop, test, simulate as per our user requirements. So virtual instruments are built and developed, simulated and tested using Labview. So with the help of Labview, the user can design virtual instruments by creating a graphical user interface on the computer. Of course, we can operate the instrumentation program, we can control the selected hardware, we can analyze the acquired data and display the results on the screen. That means whatever the things that are happening on the real time scenario can be visualized, can be tested, can be simulated in this software, and thus we can develop a virtual instrument on a software development environment which is called as Labview. That means if you want to study about the virtual instrumentation, it is the prerequisite of the learner to study or to learn the Labview software also. So Labview software is developed by National Instruments. This is a company which developed the software for the industrial purpose. Here we are going to use a graphical programming approach which is quite simple when compared to other programming languages. Here we can develop virtual instruments on this software. This Labview software is a licensed version. We have to buy this licensed version for its use. For academic purpose, faculty and students can download the Labview software from National Instruments website. But for industrial scenario, we need to buy the licensed version. Of course, we can avail the licensed version in the lab also. So this is the overview of the virtual instrumentation subject. So we can refer various topics that are related to the virtual instrumentation in the given textbooks. Apart from the textbooks, we need to learn the software Labview. The Labview software will give us a overview about the approach of designing and development of virtual instrument for the industrial usage.